We tend to see the earthquake and the actual tropical storm formation or intensity at a different time than the
Yes.
peak geomagnetic activity.
Yes. Of course, everything occurred for a reason, and before something happened, something else had to happen before. If you think about magnetic field, before magnetic field can occur, we have electric field that's occurring, and so if you think of storm as a magnetic phenomenon, which looks like a spiral vertex, and that's kind of representing something very similar to Bergen current. So that's a magnetic phenomenon. So before magnetic phenomenon can happen, you need a compression uh, of fluctuation of charge or potential, which brings uh, the electric field fluctuation. So and if we look into electric field fluctuations, we know that it needs to be compressed either from inside or from the outside. And in terms of outside would be the space weather phenomenon. The inside fluctuation, we know that it linked very well to earthquakes. So, so those two are quite connected, and that's one of the reasons why we typically see um, earthquake occur before tropical storm or after the tropical storm.
Hmm.
Because it's a signature of fluctuations of electric field, or some researcher kind of refer that to electrostatic oscillation, and not electromagnetic. So so when when earthquake occurs, that's causing a rise in fluctuation of charge, then it produces electrical discharge, and those electrical discharge phenomenons come afterwards uh, and produce current, and current produce heat and vibrations and other things. So, and those electrical discharge phenomenon typically link pretty well to electromagnetic phenomenons of radiation. So that's a kind of storm, tropical storm formation, geomagnetic storm. Those two are kind of linked, but they not occur at the same time with the earthquake.
Yeah, that makes sense
Yeah.
because you wouldn't have the instability, if you will, at the same place at the same time. It would move through the system, and so
Yes.
that makes perfect sense. You know what's interesting? We saw the earthquake and tropical storm formation really hold true when the storm season was still strong for New Zealand and Northern Australia. And now we're seeing it in Mexico and the Bay of Bengal. But I got to tell you, over the last 2 years, the place I've seen it strongest, I think, is the Philippines.
Mm-hmm.
It's like every time there is a low pressure system that heads near there, especially if it gets anywhere near typhoon status, the Philippines are going to have an earthquake. It happens almost every time. And, we haven't had a bigger one in the Philippines. And, I would like to say months. It may be merely weeks, but it's still, it's a big earthquake zone being a part of the western areas of the Ring of Fire. And I think that as typhoon season gets back into gear, the Philippines need to gear back up for some earthquakes.
You know that we have significant earthquakes today, right?
Yes, in Greece.
Yes. So you know that in the presentation I did at the Universe, I only present a case study when it's actually occur at the maximum sunspots.
Hmm.
But in reality, it's actually occur during the minimum sunspot too, when the sunspot kind of drops rapidly. And if you look at the sunspot number, you see that it's actually a sharp drop, which occurred a day or two ago.
Yeah.
And without having to look into a lot of other index, we know for sure there's going to be some significant earthquake.
Yeah, and as fast as it dropped off, it's already started, ping-ponging back the other way. There was a
Right.
delta spot that formed overnight on the departing limb, and
Yes.
there's actually going to be a sunspot collision on the in the incoming spots on the back side of those ones that are in the south eastern quadrant. The backside group is spreading laterally so quickly that the lead umbra, it looks like it's going to collide with an umbra out in front of it, which is pretty interesting.
Yes. You know that what caused the change of sunspot, right?
No. What?
This is something I haven't talked about, but we can actually predict solar activity before it happened, and it has to do with how the solar system works. And you probably heard the familiar theory of planetary alignment.
Oh, of course. Yes. Are you talking about the planets that are further out and how they regulate, like Neptune?
Yeah. There's a theory behind it, and it's actually a simple theory than most people think, but it has to relies on everything as a whole is the same system, not just a dot of planets, and it's actually related to space surrounding it and how the whole thing act as a big electrical circuits, big electrical resonance circuits, and during this time, yes, there's some significant alignment, and we people like to argue is gravitational force is not.
Oh yeah. There's so much more
It's
than
not-
gravity at play. There's so much more
It's
than
not
gravity.
gravity. Listen, this is not a gravitational force. I will tell you, it's electrostatic oscillation, and it's linked to ether, and the way it works is it's not that hard. It's like it works like sound wave if you think about it.
Mm-hmm.
Sound wave rather than electromagnetic. And you imagine sound wave instead of having sound. Sound is air, which is a medium of vibration, right?
Mm-hmm.
You have space as a medium of vibration, and space itself contains charge, and those charge it's a symptom of vibrations, and it's a longitude vibration, just like sound. And there's a node. It's called resonant node. That's actually placed along each orbital path of planets, and that's how the planets got locked into the orbit in the circular rotation without spiraling toward the sun. And so it's a resonance locked circuit, and each planet's also locked to a position, a specific position in that orbital path. Okay, and that so it's not a random position that the planet's orbiting around the sun, but it's actually a phase locked position, and it locked to the resonance vibration along its orbital path, and most of the time you cannot see it, but you see it as a really small fluctuation. For example, I can give you an example for the Earth. The Earth has season. There are 4 seasons, right?
Yeah.
Typically, and those season is set by the alignment between the Sun, the Earth, and the galactic plane. That's why we have December 21st is the winter solstice.
Mm-hmm.
It's not just about the inclination of the planets,
Yeah.
like what we are taught.
That would be probably one of the most ridiculous coincidences in the world. I remember the first time I found out that on the solstice, The solstice for both winter and summer, regardless of which hemisphere you're in, there was
Yeah.
an alignment with the center of the galaxy, and someone was trying to tell me that that was just a coincidence, that it was all about this tilt of the Earth, and I was like, okay, maybe it's about the tilt of the Earth, but then, of course, something about the tilt of the Earth must have to do with that
Yeah.
galactic alignment, then, right?
It's a fate mechanism.
It's what?
It's a fate lock mechanism. That's why the winter start on that day, and you also have summer start on the opposite, right? Opposite
Yeah.
position, and you also have spring and autumn start in the 90 degrees from that alignment, right? So you have four quadrants, so they are 90 degrees. So all these positions are significant. They are locked between three different objects, right? The sun, Earth, and this one is galactic. And then from there you have 90 degrees from it, which is another locked position. So you see around one orbital path of the Earth, there are four locked positions already. And if you imagine each planet, they're circulating, and if you consider any three objects that are aligned, so they have a locked position of four quadrants as well. And then you combine all those for all those different combinations, you got a significant event. You know when it's going to occur. So when all those planets are phase locked, and as I would like to address that the planets, even though it looks like a dot, it locked to the space surrounding its orbital path. So the vibration actually, even though it's invisible, is actually, if you see from the top view of the solar system, you see it's actually interactive things of the whole entire space surrounding that dot. Not just that dot, but actually surrounding the solar system, surrounding all the orbital path. So we cannot just treat the planets as a dot anymore, because it's just a part of the stable node of those space. So you can have many different combination of stable nodes for many planets, and when they are locked into position, they are in phase or tangent quadrature from it. Then you have instabilities, maximum instabilities or maximum stabilities, and that's when the sun erupts.
Yeah.
Into instabilities, a sudden instabilities, and this is the reason why we have. If you look into even sunspot, probably easiest way to track, because it's a really well-known index. Each time when there's a dip in sunspot number, and we take a look at what planets are aligned, you know that one significant one I can tell you right away is the Saturn. So when Saturn align with the inner planets, the Venus or the Mercury, you'll see a sudden drops in sunspot around that day, and then that's when you will have earthquakes and other things. which is a sudden fluctuation of space. So that's why we have sudden fluctuation in space weather as well, even though the sun doesn't seem to be active much. But it does correlate in terms of minimum, you know.
Absolutely.
So the maximum and the minimum, and it ties well with the resonant vibration of space. It has nothing much to do with gravity, and this is something that the current understanding of science just had not been through this, but there's so many people have been observing this connection for a very long, long time. So, and hopefully I got a chance to talk more about it. It's better to show experiment than just talking, you know. But it has a lot to do with semantic experiment, and you can actually take a look at that on YouTube.
Oh well, hey, I'll tell you what. I'll definitely take a look at that on YouTube. And when the Mobile Observatory project comes to Arlington, Virginia, I'd
Yeah.
love to film some of that and put it in the documentary we're making.
Okay.
I think that your work should be featured among the stuff that we're going to be showing there as much as possible. In case you couldn't tell, we love you over at the Observer. So